My combat robot Cinnamon Roll just took first place at its last competition. That's not good enough. Some fights were just too close for comfort. The issue is that I can't capitalize on every opening, usually because I can't get under control fast enough after a big hit. So the problem is me. It's a skill issue. I want to fix that, but I need to figure out what it is I'm doing wrong first. So I designed a custom telemetry recorder, went to another competition, and got some data with the hope of actually learning something. Here's how it went. So, after each event I go to, I always try to come up with some ideas for improvements based on the things that went wrong or broke on the robot. Since Cinnamon Roll won its last event in February, though, I'm in a bit of a weird situation. I'm already pretty happy with the physical design because it held up really well, but I still want something to work on. The biggest issue, and the thing I need to work on the most, is honestly my driving skill. A lot of this comes down to the fact that my test box isn't really big enough to properly practice, so I can only get a real driving experience at competitions, at least until I can build a bigger test box. Since I can't build that bigger box just yet, I need to maximize the amount of learning that I can do from each competition match. I already take videos of each match to rewatch, but it can be hard to tell exactly what I'm doing at any given point in time. This gave me the idea to build a system that logs every single input I send to the robot so that I can know precisely what I'm doing at any given moment. Usually, with things that record telemetry, the inputs will be sent to a computer that stores the data. Often with things like drones, this is stored on board where it can be downloaded later. Unlike a drone, though, I don't actually want to put any logging system inside the robot. First, it's gonna add weight and complexity to the robot, which is already constrained by a weight limit. Second, and more importantly, if my robot gets destroyed or catches fire, all of that data would be lost. If that means the data has to be stored off of the robot, then the next obvious place for it to be would be on the remote. EdgeTX, the transmitter software, does have an option to record input data, but unfortunately the sampling frequency is just too low. I want something much faster so that I can see rapid changes in inputs and also match it up with the camera frame rate to create visual overlays for videos. All of my design requirements left me with one conclusion. I need to make a custom device to capture and record the data at the sampling rate I want. Thankfully, ELRS, the radio communication protocol, has a way to kind of make this work. It can actually be set up so that more than one receiver can be bound and listen to a single remote. So, the plan is simple. With one receiver already in the robot, I'll pair a second receiver with my remote, so that both my robot and the second receiver get all of my controller inputs. Then, a microcontroller will be attached to the second receiver to read all of the signals coming in and save them. For this project, I ended up selecting a Seed ESP32S3 Sense for the microcontroller. It's small, reasonably cheap, and comes with a camera, but the real reason I chose it is because it already has an SD card attachment. This will let me store a lot more data and make it much more convenient to access the files because I can just plug the SD card into my computer. The ELRS receiver I ended up using was an older Happy Model one that I had on hand, which talks to the ESP32 via UART. Some Arduino code on the back end reads the UART signal and tells the microcontroller when to listen and when to record the data to a CSV file. After an event, I can use a Python script to make charts from the data and animated overlays on the match videos for review. With the basic concept laid out, I started by making a breadboard setup and doing some simple tests. Once I knew it was working, I taught myself some KiCad and designed a simple PCB to hold all of the components in place. I then ordered and hand soldered all of the components to the PCB, which got put inside of a custom 3D printed case I designed to mount to the back of my transmitter and feed off of the radio's battery. This setup means that because I need my radio to be on for a match, the recorder is also always on at the same time, and I never have to even think about it. After making sure that it was all working, I took my new setup and Cinnamon Roll to Virginia Tech's spring competition. As I recap these fights, I'll use the data I collected to add a custom overlay to show what Cinnamon Roll was actually doing as I discuss what happened. On this overlay, the arrows on the left and right side show whether the drive motor was going forwards or backwards, and the dial in the center will show the weapon throttle. At this competition, there were a couple of initial rounds that determined a robot seed for the final single elimination bracket. For Cinnamon Roll's first seeding round, its opponent was Bypass, a horizontal mid-cutter.
3, 2, 1, fight!
Unstick. Unstick.
Pause. 3, 2, 1, resume.
Cinnamon Roll won this fight by judges' decision, but it certainly didn't feel like it because it was such a mess. Right off the bat, I tried to spin Cinnamon Roll up to full power before moving, but it lost grip and the blade hit the ground. I had tried testing this in my test box a bunch of times before the event and had no issue, so I also tried to go right up to full speed again at the next chance I had, which also just didn't work. My best guess as to what's happening is that the floor of the arena is much dustier than my test box. This results in less grip on the floor, which limits how fast I can spin up. Another thing I caught looking at the data was this interaction later in the match. Here, the data shows me that I make the mistake of choosing to reorient the robot instead of spinning up first, which leads to Bypass getting multiple free hits and damaging a shuffler. Again, I won this fight by a judge's decision, but ultimately I didn't feel in control for most of the match, which is important. The bad habit the data showed was that I was trying to focus on squaring up before spinning up, so that's something I'll work to avoid at future competitions. The next seeding match Cinnamon Roll entered the box for was against Drum Mulcher, a beater bar robot mostly based on a kit. Knowing that this was a kit robot, I figured it would be fun just to spin up and go straight for weapon-on-weapon impacts to see what would happen.
3, 2, 1, fight!
This was a much shorter match, so there was a lot less data to look at. Even without processing the data, I knew from my last fight that the floor was dusty, so I was much more cautious spinning up at the beginning of the match. The more careful approach was slower, but Cinnamon Roll stayed planted the whole time. One more interesting quirk I caught from the data was that when chasing down Drum Mulcher for a second time, I made a quick reverse in turning direction. Reversing in this direction introduced just enough gyroscopic forces to cause the blade to dip and hit the floor, which made Cinnamon Roll lose control. Again, another thing to keep an eye on. With the preliminary matches out of the way, the single elimination bracket was set up. Cinnamon Roll's first opponent was Pickle Jar Lid, a sit and spin style robot that can either drive or spin in place. To give them the best chance I could, I decided to use the same strategy as the last match and let them spin up before just going weapon on weapon to see what would happen.
3, 2, 1, fight! Pickle jar, can you drive? 10, 9, 8, 7, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. That's a knockout.
On the first hit, slowing down the footage and looking at the inputs shows that I just missed the opponent, hitting the shuffler on them and causing Cinnamon Roll to twist and launch itself. On the next hit, Cinnamon Roll got a much better impact. After the third impact, I made the same mistake as before, spending time squaring up before actually spinning up. In this case, it didn't make much of a difference, but it still shows some of the bad habits I've unintentionally been creating. I also saw the same rapid change in direction causing issues again here, where I went from full forward to full backward, which caused the blade to wobble just enough to hit the ground. Cinnamon Roll's opponent for the semifinals match was Arrogant Burrito, a robot that had gone through a massive transformation since the last time I had seen it at an event. For this match, I decided to switch to a titanium top plate to provide a little more protection for the electronics. To make weight for this, I also switched to a thinner blade, which I figured would do a better job of slicing through Arrogant Burrito's big TPU wheels.
3, 2, 1, fight! Oh!
Untanglement?
Yeah,
Or
well,
just
you're gonna
tangle?
unstick that.
Alright.
Guys, turn off your weapons, controllers up.
Yeah.
3, 2, 1, resume. Guys ready? You
Ready.
Alright. 3, 2, 1, resume. Oh, fuck, they got stuck.
There's nothing to be about.
Tap out. That's the match.
This match was interesting to analyze because it showed both some good and bad examples of self-righting. Early in the match, I struggled to flip back over as I continued to switch between going forwards and backwards with the shufflers, losing valuable time that I could be attacking with. Later, I get a good flip after holding one direction for a while and then switching. This is definitely interesting and something I'll be sure to test and keep an eye on in the future to gather more information. With Arrogant Burrito tapping out, Cinnamon Roll was through to the finals, fighting against Refuse, a hub motor vertical robot. My goal this time was to try and go straight for the exposed wheels.
3, 2, 1, go. Now don't hold your punches, guys. Well, you're not stuck anymore. Let me count out. 10, 9,
Can we keep going?
8, 7. Just say that big. Oh. No, I'm all here for this. Like.
That's a knockout.
All right.
This match was over really quickly. On the first hit, Refuse's power switch came unscrewed, turning it off and pretty much ending the match. Reviewing it, since I wanted to go for the wheels, I decided to head left first to flank, but I realized I was going to get cut off by the much faster Refuse, so I pivoted to square up, leading to a good hit that effectively ended the match, and Cinnamon Roll took home first place from this event. All in all, I'm very happy with the system I created. It suits my needs and will definitely help me understand my mistakes better, and as a byproduct, allows me to create some cool visuals for these videos. So I think it's a win all around. If you have any feedback on it or ideas for potential improvements, be sure to let me know in the comments. Next time, I'll be scaling down Cinnamon Roll to fight in smaller weight classes. So if that sounds interesting, subscribe to follow along.